Hello everyone. Uh, Today I'm going to explain the previous year's BW question papers. This is December 2019 question paper. So let's discuss whatever the problems are there in the question papers. I will discuss those only. The remaining theory part you can go through your notes or in my channel there are so many videos regarding these theory topics, so you can go through it. But today in part B, all are long answer questions and so many problems are there in this particular paper, in 2019 question paper. So I will discuss those problems now. So it consists of part A and part B. In part A, you have to write all the questions. There is no choice. So total 10 questions will be there. So you have to attempt all the 10 questions. Each question carries 2 marks. And some questions carries 3 marks also. So comprises of 25 marks for part A, and part B is for 50 marks. This is 2019 pattern. Don't compare this pattern with your present pattern. Why? Because now you have internal marks is for 30, right? 20 marks as a internal and 10 marks as a quiz, total 30 marks as internal. So your paper pattern may be different, but whatever the questions are there, those will be same. So let's see the part B. The first question is determine the Thevenin's equivalent circuit for the following circuit. The circuit is given. We have to determine the Thevenin's equivalent circuit. It is asked for 4 marks. So first I will draw the circuit. It is not visible clearly. Question number 11, 1A. So the circuit given is 50 volts, and this is 5 ohm resistor, and this is 10 ohm, and again the 6 ohm resistor, and this is 10 volts. And these terminals are marked as A and B. What you have to find? You have to find out the Thevenin's equivalent circuit. So first you should have an idea of Thevenin's equivalent circuit. You have to draw the Thevenin's equivalent circuit first. Let us see the solution. So Thevenin's equivalent circuit consists of R Thevenin, that is Thevenin's equivalent resistance, and VOC, that is open circuit voltage or Thevenin's voltage, we can call it as. And this series combination is connected across the load resistor. But in the given problem, a load resistor is not given. So in place of the load resistor, terminals are given, A and B terminals. So we have to assume that between these terminals there is a load resistor. So in the problem it is not given. So your Thevenin's equivalent circuit will be up to here only. No need to connect the load resistor. But actual Thevenin's equivalent circuit is this. This is Thevenin's equivalent circuit. So in this, what are the unknown things? Thevenin's voltage, R Thevenin, you have to find out. RL anyway, in which resistor you are going to find out the current or voltage across it, some voltage. So that will be your load resistor. So here nothing is given, so you can remove it. So this is the Thevenin's equivalent circuit you are going to find out. So let's first find out this V Thevenin, Thevenin's voltage. So what is the procedure to find out the Thevenin's voltage? First of all, you have to know about it. So Thevenin's voltage or open circuit voltage. Open circuit means, so whenever you are finding this Thevenin's voltage, first you have to remove the load resistor. And between those load terminals, you have to find out the voltage. That will be your Thevenin's voltage. But in this case, there is no load resistor. So then where will you find out the open circuit voltage? Across the A and B terminals. So here V Thevenin is equal to voltage across the terminals A and B. So we are assuming that load resistor is connected between those terminals. So you have to find out the voltage across those two terminals. And this is open path, right? There will not be any current flowing through this 10 ohm resistor. That indicates this branch is a redundant branch. You can remove it. So just remove that branch and redraw the circuit. So this is the circuit. I'm not drawing that remaining branch. So directly the terminals will be, you can put it here. So across this AB terminal, you have to find out the voltage. That is your Thevenin's voltage. So to find out that voltage, first you have to know about the current, right? If you don't know the current, how can we find out the voltage across this branch? So you have to find out the current. So just assume the current is flowing like this in this circuit. Now you can apply the KVL to this circuit. KVL is nothing but the algebraic sum of voltage drops in the circuit is equal to 0. So for that, based on the current direction, you can mark the polarities for the resistor, plus, minus. If current is flowing in this direction, this is plus and this is minus. Always the current will flow from higher potential to lower potential. Suppose if the arrow mark is like this, then here it is plus and here it is minus. So based on the current direction, I am marking the polarities. For the battery or voltage, you no need to put the marking based on the current direction. Whatever the polarity is given, battery polarity, that you have to take it as it is. Now apply KVL. So start at any point in the circuit. So I am starting at this point. So I will trace the path, entire path of the circuit, and I will end at this point. So first sign I am seeing while tracing my path, the first sign I am seeing is minus. So I am writing minus 50 volts. The algebraic sum of voltages you have to write, right? So this is already a voltage. So you can directly write the voltage. This sign depends upon your convenience. You can take it as plus also. Whatever the first sign I am seeing, that sign I am taking here. So otherwise you can take plus also. But throughout the path, you have to maintain the same thing. And next I'm entering what? Plus again. So plus, here the resistance value is 5, and what is the current flowing in this? I. So then what will be the voltage? We know the voltage formula is V is equal to I into R. So current I and the resistance value is 5, therefore the voltage is 5I. You have to write the voltage drops, right? Next I am entering here. Again, what is the sign I am seeing? Plus. So write plus. Here the resistance value is 6 and current is I. The same current is flowing in 6 ohm also. So 6I. Next sign what I am saying? Plus. So plus 10 is equal to, after this no element is there, and I will end at this point. Where you started, at the same point you have to end. So algebraic sum of voltages is equal to 0. Now from this you can find out the current. So that is 11I is equal to 40. From this I is equal to 3.63 amperes. So this is the current value. But what is our aim? What we have to find out? We have to find out the Thevenin's voltage, not the current. Now find out the voltage. Voltage across what? Voltage across this AB terminals. So V Thevenin we are finding. So across this AB terminal, so write the elements in between A and B terminals. This is A terminal and this is B terminal, and the current passing through it is I. Already we know the current value 3.63. What is the resistor here? 6 ohm, and this is 10 volts. Now you have to write the voltage across this A and B terminals. That is nothing but VThevenin. So to write VAB, what you have to do? The current is flowing from A to B. So this is plus and minus. So what is the voltage drop across the 6 ohm? 6 into I. V is equal to I into R. Current is I and resistance value is 6. So 6I. Next, plus, what is the voltage value? It is already there. It is 10. 6I plus 10. So current value, we know that is 3.66 plus 10. This will give you the voltage 31.81 volts. Next, you have to find out RThevenin. So in the equivalent circuit, we have VThevenin and RThevenin. VThevenin is over. Next, you have to find out the RThevenin value, equivalent resistance. So to find out RThevenin, what we have to do first? First, the condition to find out the RThevenin is you have to replace all the voltage sources with short circuit, and if there is any current sources in the circuit, you have to replace with open circuit. Is it clear? While finding the RThevenin, first what you have to do? You have to replace all the voltage sources in the circuit with short circuit. So there is a 50 volt source, make it as short circuit. This is 5, 10, 6, and this here 10 volts is there. That is also I am short circuiting. So this is the circuit. You may got the doubt. In the previous case, while finding the VThevenin, I didn't consider this branch, 10 ohms branch. I told it is a redundant branch. Current is 0. It is an open path. Open path indicates current 0. So we can neglect this branch while finding the VThevenin. But while finding the equivalent resistance, you should not neglect that branch. Even though the current is 0, we are just finding the resistance value. So don't bother about the current. So you have to include that resistance. But while finding the voltage, you can neglect. This is 5 and this is 10 ohm. So between A and B terminals, again, you have to find out the equivalent resistance. So if you see this 5 ohm and 6 ohm, suppose let us current is passing like this. At this point, the current is dividing. 5 ohm and 6 ohm are in parallel. 5 parallel with 6, and that parallel combination is in series with 10 ohm. So you have to add 10. If two resistors are in parallel, R1, R2 are in parallel, then what will be the equivalent resistance? R1, R2 by R1 plus R2. So 5 into 6 by 5 plus 6. So you will get the equivalent resistance. That equivalent resistance is in series with this is 5 parallel 6 resistor and this is 10. So you have to add. If two resistors are in series, you have to add those two. This is the 5 parallel 6 value and this is 10 ohm. So the total value will get it as 12.7. So now we got the Thevenin's voltage and RThevenin. Just replace these values in the equivalent circuit. That will be the answer. So equivalent circuit is VOC value, we got it as 31.81 volts, and RThevenin value we got 12.72. This is RThevenin. So this is your equivalent circuit. That's it.